now that we know how the ROS2 services work and how to use them in a real use case, let's add a new functionality to our C++ node that manipulates the TF frames using the ROS2 services. Basically, we are going to add a service server which provides the current values of the transformation matrix among any two frames that are available in the TF or TF static topic. So once again, back in Visual Studio Code, let's continue modifying within the BumperBot CPP examples and within the include folder the simple TF kinematics.hpp. Here we are going to add a new service server to the simple TF kinematics class that will provide the values of the transformation matrix among any two frames selected in the request message. To do so, among the private variables, so here let's create a new service class. So from RCL CPP, let's create a new service class, and actually let's take a shared pointer to this class and let's call it, so this is shared pointer, and let's call it get transform service. And among the angular brackets of this template class, we need to indicate the communication interface that has to be used in order to communicate with the service server, so the one that defines the request and the response messages. So first we need to define such an interface, so we need to define the message interface that this service has to use. And if you haven't followed me in the Python lesson, then still within the BumperBot messages package, still within the service folder, you need to create a new interface called getTransform.srv. And here we need to define how the request message is done, and this is composed just of two strings, so which are the names of the two frames that we need to transform. And so the first one is called frame ID and the second one is called child frame ID. Then by using 3 dashes we can also define the response message, and so this is given by a transform stamped message that indicates the actual transform between these two frames, and then a boolean variable called success, which indicates whether or not the server was able to calculate the transform between the two selected frames. Also, in order to compile this new message, in the cmakelist.txt, the first thing that we need to do is to add the dependency from the geometry messages, as here in the definition of the message we have defined a variable, so the transform variable of type transform stamped from the geometry messages. And also here within the ROS IDL generate interfaces, after the add to int service, we can also declare now the get transform service, and also we need to add the dependency from the geometry messages in order to indicate that this interface here is actually using this library here. Also within the package.xml that is in the BumperBot messages package, we need to add the dependency from the geometry messages package, and so actually this is all we need in order to compile and to declare this interface here. So now, before being able to use it within our BumperBot CPP example, and so within our simple TF kinematics class, we need to build our workspace. So after defining a new interface, we need to build the workspace with the command called conbuild. And so now at this moment we are able actually to include from the BumperBot messages and from the services, now we can include the one that is called get transform.hpp, and we can use it here. So from the BumperBot messages and from the services, let's take the get transform service interface. Next, once we have the service object, we can also declare its callback function, namely the function that is executed whenever the service server receives a new request message. So still among the private members of the simple TF kinematics, let's define the get transform callback function like this, and this function takes as an input an object of type, so it is a shared pointer, and this is a shared pointer of type bumperbot messages service get transfer request, and so this is the request message, and also then there is the response message. So actually we can copy the first input and we can paste it here, and we just need to change that the second one is of type response, and let's call this variable response, like this. Moving on, to get the transformation between the frames that are available in the TF and the TF static topic, so in order to interact with the TF library, we need to import two more classes from the TF2 library, and these are the transform listener and the buffer class. So here, let's include from the TF2 ROS library the buffer module, and also let's include still from the TF2 ROS library the transform listener, like this. And then we can create two new more private member variables of the simple TF kinematics class. So still here among the private variables, let's create a unique pointer to an object of type TF2 ROS buffer, and let's call this one TF buffer, like this. And then also let's create a shared pointer like this to an object of type TF2 ROS transform listener, and let's call this one TF listener, and we can already initialize this one with a null pointer, so at the moment of its declaration, like this. Now we have declared all the members and all the functions that we need, and so we can define now their behavior within the source folder and within the simple tf kinematics.cpp. Here in the constructor, let's start by initializing the tf buffer variable. So we can do it here. So the tf buffer that we have just created, and this is an unique pointer, so we can initialize it with the make unique function. So this is a template function, and among the squared brackets we need to use the tf2 ROS buffer, so this belongs to the buffer class, and its constructor takes as input the ROS2 time, and we can access to this time by using the get clock function. And then let's also initialize the tf listener. So the object tf listener, this is a shared pointer that we can initialize with the make shared function, and this is a shared pointer of an object of the class tf2 ROS transform listener, so like this, whose constructor, so here among the parentheses, it takes as input the instance of the tf buffer, so the variable tf buffer, and also let's dereference this pointer. Next, still in the simple tf kinematics class, still in its constructor, let's also initialize the service server. So here, after the timer, let's also initialize the get transform service, and we can do so with the create service function, like this. And here, among the angular brackets of the create service, we need to indicate the type of the interface that we want to use for this service server. And so again, this is in the bumperbot messages, in the service, and it's using the get transform interface. Then among the parentheses, we also need to indicate the name of the service, so the name that other ROS2 node can use in order to request the service functionalities. And let's call it get transform, so like this. And then we can also set the callback function that has to be executed whenever the service receives a new request. Again, we can use the bind function, and from the bind function, actually we can access to the simple tf kinematics class, and we want to execute the get transform callback function. Also, let's pass the pointer this in order to indicate that we want to execute the get transform callback function that is declared in the current object, so in the current implementation of the simple TF kinematics class. And then let's also declare the usage of the namespace placeholders. And from this namespace, here we want to use the placeholder number 1 and the placeholder number 2 to indicate that basically this function here, so let's format it better, the get transform callback function receives actually two input, so two variables as input, which are exactly the request and the response message, which belong to the get transform interface. Finally, in the simple TF kinematics class, we just need to define this function here, so the get transform callback function. We can copy its declaration from the header file and let's paste it here. So let's define this function, and also here let's communicate that we are not defining a new function, but actually we are defining the behavior of the get transform callback, which is already declared in the simple TF kinematics class, like this. Here in this function, whenever the service server receives a new request, let's start by printing a message in the terminal with rclcpp info stream. So let's use the get logger function in order to print the message requested transform between, and then we can print the name of the two frames that we want to transform. And so basically from the request message, the frame ID, and also still from the request message, the child frame ID, like this. Then we can actually read the transform between the two frames that were selected. And so we can first create an instance of the geometry message transform stamped, which will contain the output of the transformation between the two selected frame, and let's call this variable requested transform, like this. And to obtain the transform between any two frames that are published in the TF and in the TF static topic, we can use the lookup transform function from the buffer library. So again, let's use the TF buffer object, and from this one let's use the lookup transform function, and this one, so this function here, will return a transform stamped message, so a message of this type. And so actually let's store the output of this function within the requested transform variable. The lookup transform function, so this one here, requires 3 parameters as input. The first one is the name of the parent frame that we want to transform against, and so this is the frame ID that we received in the request message. So from the request message, this takes the frame ID, and the second one, so the second input, is the child frame ID that is still in the request variable, and that is called child frame ID. And then it also receives a third argument that is instead the time at which we want to know this transformation, so the transformation between these two frames. Let's take, for example, the latest available one by using the TF2 time point 0. So basically with this macro here, we are accessing to the latest available transform. In case this function, the lookup transform, is not able to calculate, to extract the transform between these two frames, so the frame ID and the child frame ID, it throws an exception. So let's try to catch this exception. So let's use a try catch statement. So let's try to calculate this transform, and if it throws an exception, so if the lookup transform throws an exception, so let's catch any exception of type TF2 transform exception, and let's call this one exception. In this case, let's print an error message in the terminal with rclcpp error stream. And so let's get the logger and let's print the message an error occurred while transforming from, and here let's print the frame ID. So from the request message, let's access to the frame ID, and here let's print still from the request message the child frame ID. And also let's print the content of the exception. So to the X variable, let's access to the what function, which explains basically the error. Let's format this a little bit better so that we can easily visualize it. And in this case, so in case the lookup transform function throws an exception, let's set the variable success that is in the result to false, like this. And in this case, let's return true. So let's already terminate the execution of the callback function. So let's terminate the execution of the service server. Next, so if we are outside the cache, it means that we were able to calculate the transform between the frame ID and between the child frame ID. And so in this case, instead, let's set the success to true, and also in this case let's return true. With this we have implemented all the functionalities for our simple TF kinematics, and also for our service server that can calculate the transform between any two frames and can use the get transform service interface. Now let's see how all of this works. So let's open a new terminal, let's go to the workspace, and let's build it with colcon build. Here we have an error because it says that the get transform is not recognized, and this is because here we have used the dependency from the bumperbot messages, and if we go to the CMake list and actually to the simple TF kinematics, here we can see that we have not declared this dependency. So let's add the dependency from the bumperbot messages to the simple TF kinematics. Now let's build again the workspace. And now let's open a new terminal. Let's move it on one side. And here let's start by launching rvis2. In order to start and configure rvis2, here let's change the fixed frame ID to be the first frame that we are going to publish in our chain, which is the add-on frame. And then let's also add the visualization of the TF, so the TF plugin, like this. So now our rvis is configured, and we can start our simple TF kinematics node. So in a new terminal, let's source the workspace, and let's start our node, so with ROS2 run, and from bumperbot cpp example, let's start the simple TF kinematics node. So let's press enter, and now we can already see the three frames, so the bumperbot base, the bumperbot top, that are moving with respect to the add-on frame that is fixed. Now we can start by using our service, so the service that we have implemented. And if we open a new terminal, actually like this, and here if we use the command ROS2 service list, we can see that we have the get transform service that we have just created. And actually we can start using this service, so we can send a call to this service by first sourcing the workspace also in this terminal, and then let's use the command ROS2 service call, and let's call the get transform. Then let's press tab twice, and we can see that it is automatically detected the type of the message that is accepted by this service. So let's insert it, then let's use the double quotes, let's press again tab twice, and this is the empty prototype of the message, so of the request message that is accepted by this service here. So let's type the letter F, then let's press tab, and now we can insert the two frames that we want to transform. So the two frames among which we want to calculate the transform. For example, let's calculate the transform between the bumperbot base and the bumperbot top frames. So let's press enter. Here we can see that there is an error since we are receiving basically an empty transform, and so we can see that the frame ID and the child frame ID is empty. And so the error, if we go back to our script, is here because we haven't updated in the response message, we haven't updated the transform with the requested transform variable. So here the requested transform variable is initialized with this transform here between the requested frames, and also we need of course to insert this transform within the response message that we need to return to the client. So back in the terminal, let's build again the workspace with these changes. And now if we execute again the same command, so here we need first to stop the node, we can restart it, and we execute the same command. Now we can see that the response is actually correct. So we are getting the transform between the bumperbot base and the bumperbot top frame. And here we have the translation vector. So we can see that it is translated 0 along the x-axis, 0 along the y-axis, and the bumperbot top is translated of 0.3, so of 30 centimeters along the z-axis. And this is the rotation matrix, so this is the quaternion that expresses the orientation among the bumperbot top and the bumperbot base, and we can see that it is 0, 0, 0, and 1, and this expresses that the bumperbot base and the bumperbot top frame are oriented the same way. We can see that if we launch again this same command and we request for the same transform among the same two frames, we get the same response. So actually we get the same value for the translation vector and the same value for the rotation matrix, and this is because the transformation among the bumperbot base and the bumperbot top is a static transform. Instead, if for example we get the transformation between the odd-on frame and the bumperbot top, so if we press enter, now we can see that the translation along the x-axis is 42 meters, and if we launch again this command, now the translation along the x-axis is increasing as the bumperbot top frame is moving with the bumperbot base frame with the respect to the odd-on frame, and so it is moving along the x-axis in the x direction. Now, if for example we try to get the transform between two frames that doesn't exist, for example let's ask for the transformation between the odd-on frame and the bumperbot camera frame, where of course the bumperbot camera frame doesn't exist because we are not publishing it. If we press enter, we can see that the service server returns an error, and so that it wasn't able to transform between the odd-on frame and the bumperbot camera frame, as the bumperbot camera frame doesn't exist.